Hi, welcome back to this channel. This video going to discuss about solubility equilibrium, and these are the objective. We need to know the definition of solubility, molar solubility. Basically, the unit for molar solubility is mole per liter, while the solubility unit can be either in gram per liter or mole per liter. So to make it not confused, normally solubility is referred to gram per liter. And also we need to know the definition for the solubility product, which is represented by the KSP. When we are given the KSP value, we're able to determine the concentration of ion. The other way around, if you are given the KSP value, then we can determine the concentration of the ion. Next, we are going to predict whether precipitate will be formed or no by comparing the Q with the K. Then we are going to discuss about the common ion effect and also do the calculation. Let's start with tutorial question number 1. Write the equation and also the solubility product expression. So in this question, there are two requirements. So basically, all the chemical equation is shown in here. So now we goes to the part of the solubility expression. So KSP for copper 1 bromide will be equal to concentration Cu plus multiply with the concentration Br negative. While for the B is KSP equal to Zn2 plus multiply with the concentration C2O4 2 negative. Okay, there is no power here because the ratio over here is 1 to 1. Okay, and also zinc ZnC2O4 and CuBr is not as appear in the KSP expression because solid and liquid do not appear in KSP expression. So proceed to the C. KSP will equal to concentration Ag plus rise to the power of 2 because the stoichiometry is 2 over here, and concentration of CrO4 2 negative. The last part of this question, question D, KSP will equal to concentration Mn2 plus rise to the power of 3 and then multiply with concentration PO4 3 negative rise to the power of 2. Okay, now let's look at the calculation question for the molar solubility and also solubility product. So the first example, you are given the solubility of silver sulfate, which is in mole per liter. Silver is Ag plus, sulfate is SO4 2 negative. So we know the unit for this compound will be Ag2SO4. Calculate the solubility product of the salt. So means that they ask us to calculate the KSP value. So generally, when you are given the molar solubility and you are looking for the KSP value, first write the equation. Second, write the formula. Third, substitute the value. And then next, calculate the answer. So we already write the equation. Based on the ICE table, we only focus on the concentration at equilibrium. Because silver sulfate is the solid, so we will not involve it in the ICE table. So initially, there is no Ag plus and also SO4 2 negative, so 0. So and then based on the equation over here, concentration Ag plus will getting more and more, and concentrations SO4 negative also getting more and more. So the ratio for the coefficient here is 2 to 1, so that's why it's 2x and x. So 0 plus 2x will equal to 2x, 0 plus x will equal to x. So that is why we just need to write down the equilibrium rule is more than enough. Then next, we're going to write the KSP expression. So Ag plus is 2x, and then here with the square, so 2x squared. Concentration SO4 is x. So press the calculator, we will get 4x cubed. So the S is the molar solubility in this case. So the molar solubility is this one, which is given in the question. So substitute in, press the calculator, you will get the KSP value is 1.35 exponent negative 5. KSP value also similar with KA, KB, KC, and KP. That is dimensionless. No unit is needed. Next, go to the example 2. It was found that the KSP value of the silver bromide is 5.35 exponent negative 13. Okay, this time we are given the KSP value, and then we need to find the solubility in gram per liter. So indirectly, because we are given the KSP value, so we are able to determine the molar solubility. The unit for the molar solubility is mole per liter. But then when we look at the question wants us to find the solubility in gram per liter. So if there is mole per liter, we want to convert to gram per liter. So we need to multiply the molar mass of the compound. So let's continue with the working step. Step number 1, write the equation for the silver bromide. Next, we write down the equilibrium rule for the silver bromide. Then we write the KSP expression, substitute the value of KSP into the expression, and then we are able to find the molar solubility of the silver bromide. Okay, this is the molar solubility. Okay, and then press the calculator, we will able to get from the molar solubility, we convert to gram per liter. We are going to multiply with the molar mass. So we will get the answer 9.28 exponent negative 5 gram per liter. Example, before we proceed to tutorial question. This time you are given the molar solubility, and then we will need to calculate the solubility product. Molar solubility given, calculate KSP value. So as usual, we need to write the equation, and then we write down the concentration of Pb2 plus and Cl minus at equilibrium, and then write down the KSP expression, substitute the value into the KSP expression, and then you will notice that the KSP value is 1.64 exponent negative 5. Now let's continue to tutorial question number 2. Given the KSP for the calcium sulfate is 2.4 exponent negative 4. As we know, calcium sulfate, calcium 2 plus, SO4 2 negative. So the formula for this compound is CaSO4. Then we need to calculate the solubility in gram per liter. So step number 1, we're going to write the equation. Calcium sulfate solid, reversible arrow, produce Ca2 plus aqueous, and also SO4 2 negative aqueous. So then we need to have ice table. So we have no idea what is the initial concentration for the calcium sulfate because they are in the solid form. So we can ignore the calcium sulfate column. Then initially there is no Ca2 plus and no SO4 2 negative in the solution. But after a time, the calcium sulfate is slightly dissolved and it will produce calcium 2 plus and also SO4 2 negative, at where we have no idea what is the actual value. So we represent it by the unknown x. So at equilibrium, there is x mole per liter of calcium 2 plus, and so for SO4 2 negative. Then we are write the KSP expression equal to concentration Ca2 plus and also concentration SO4 2 negative. So, and then the KSP value is given in the question, which is 2.4 exponent negative 4, and then concentration Ca2 plus and XaO4 2 negative is X. So from here, we can get the square root for 2.4 exponent negative 4. We get the answer is 1.55 exponent negative 2. As here, normally for the ice table, the unit is in mole per liter. So means that now here, after we get the value of the X, the concentration of Ca2 plus is 1.55 exponent negative 2 mole per liter. Then the next one, concentration Ca2 plus, same with concentration SO4 2 negative, also similar with concentration calcium sulfate, which is equal to X, and the value is 1.55 exponent negative 2 molar. Okay, so if now we have the unit of mole per liter, and then we need to convert to gram per liter. So the relationship between mole and the gram is we going to multiply with the molar mass. So in this case, the solubility of calcium sulfate in gram per mole will equal to 1.55 exponent negative 2 multiplied by its molar mass, which is around 136.2. Press calculator, you will get the final answer is 2.11 gram per liter. Question number 3. Calculate the concentration of the ion in the following saturated solution. So basically, saturated solution means Q will equal to KSP. So that's why we can directly use the KSP value to help us to determine the concentration. So let's say now we have a solution which is silver iodide AgI. It will dissociate to produce Ag plus and also I negative. Okay, then now we are given the value for the concentration Ag plus and also KSP value. So based on this equation, we are able to write the KSP expression, which is equal to concentration Ag plus and also concentration I negative. Given 8.3 exponent negative 17 for the KSP, concentration Ag plus is 9.1 exponent negative 9, and concentration I negative is an unknown. So press the calculator, we will get the concentration of the iodide is 9.12 exponent negative 9 molar. Okay, now let's continue to question B. We have aluminium hydroxide, solid, dissociate, Al3 plus aqueous, and 3 more of OH negative aqueous. KSP expression this time will equal to concentration Al3 plus and concentration OH negative to the power of 3. Now in this case, the KSP value given is 1.8 exponent negative 33, and then concentration aluminium 3 plus has no idea. Concentration OH negative given in the question is 2.9 exponent negative 9 molar. So press the calculator. Concentration Al3 plus will equal to 7.38 exponent negative 8 mole per liter. Next, we are going to determine or predict whether the precipitate is formed or no. Generally, we will comparing the value of Q and K. If Q is less than K, means that the solution is unsaturated and more solute can be dissolved. If the Q equal to K, means that it's already achieved equilibrium, so the solution is considered saturated solution. So if you're adding more solute into the container will become the supersaturated solution because no more solute can be dissolved at this moment. If the Q value is more than K, so means that the condition now is supersaturated solution. So the condition is it will become unstable and may form crystal. Just like what we learned in chapter 6, comparing the Q with the K. So if the K is more than the Q, the reaction like the Pac-Man will shift to the right to achieve the new equilibrium. So when we write the chemical equation, for example, we have AgBr solid, reversible is Ag plus aqueous, and Br negative aqueous. So when move to the right side, more salt will be dissolved and no precipitate will be formed because they are in the aqueous form. Let's continue with tutorial question number 4. So now you are given a solution, and in the solution here, the concentration of Ba2 plus is 2.3 exponent negative 3, while the concentration of carbonate is 4.7 exponent negative 5. Means that you are mixing two different solutions, and then you want to see whether the precipitate of barium carbonate will be formed or no. So now we have the KSP value, and then they give us the concentration, ask us whether precipitate is formed or no, means that we need to calculate the value of Q. So before we can calculate value of Q, we need to, as usual, we need to write the equation. Barium carbonate solid dissociate will produce Ba2 plus CO3 2 negative. So the QSP expression is concentration Ba2 plus and multiply with concentration carbonate. So substitute the value in, and this is the value for the QSP. Then now we need to compare the QSP with the KSP. So KSP given is 8.1 exponent negative 9, while one QSP that we calculate is 1.08 exponent negative 7. So negative 7 is greater than negative 9. So means that the system will shift to the left, and then the precipitate is formed. Okay, now continue with the last part of this video, common ion. So what is the common ion? According to the definition, the common ion is referred to the ion that is common to two or more components in a mixture of the solution. So for example, we try to dissolve the silver nitrate in the sodium sulfate. So now in this container, we have both compound. And here we notice that the SO4 2 negative is appear in both compound. So SO4 2 negative will be the common ion. Now let's do one example. When we try to dissolving lead 2 chloride into the lead 2 nitrate, so in this case we will notice that the common ion in between these two in between these two substance is the Pb2+. So common ion can be either positive charge or can be either negative charge. The main point is they must be common in two or more compounds. Now let's discuss theoretically how the common ion will affect the solubility So when we adding a common ion into the solution, generally it will decrease the solubility. Okay, this is the so-called like the conclusion for this common ion effect. So now let's see how the common ion can decrease the solubility of the salt. If you adding the AgCl into the NaCl, so the Cl negative is the common ion. So then you are increasing the concentration of Cl negative. So according to the Le Chatelier principle, when you increase the concentration of Cl negative to the system will be opposed to reduce the concentration of the Cl negative. How the system reduce? By consuming it. So means that the Cl negative will act as the reactant. So when the Cl negative want to act as the reactant, the equilibrium position will going to shift to the left. So that here will be the reactant and then the left hand side will be the products. And due to shift to the left, then more silver chloride will be formed, and this means that solubility of the silver chloride is decreased. Tutorial question number 5. We need to do the molar solubility for the PbBr2 when it is in the pure water, KBr, and also lead to nitrate. So because we are given the PbBr2 over here, so basically we can see that in pure water there is no common ion effect. For the KBr, the common ion is the Br negative, while in the Pb nitrate, the Pb2 plus is the common ion. So as usual, this question 5A1 basically is quite similar with the tutorial question number 2. Okay, in pure water, like usual, we have to write down the equation first. And then we're going to have the ice table. So because again, lead 2 bromide is solid, so we can ignore this column. Initially, Pb2 plus and Br negative are 0. And then after the PbBr2 dissolve, the concentration of the Pb2 plus and Br negative will be increased according to the ratio 1 to 2. So that's why x and 2x. So to make it simplify, basically you can just write the rho of the equilibrium. Then next we are going to write down the KSP expression. Okay, KSP expression will be referred to the chemical equation. KSP equal to concentration Pb2 plus and then concentration Br2 negative need to rise to the power of 2. And then because in this question, we are given 8.9 exponent negative 6, which is the KSP value. So the concentration of Pb2 plus has no idea, which is the x. And concentration Br negative is 2x. And then don't forget the power 2 here. So when we expand all these, it will get 4x cubed. So and then press the calculator, you will notice that the molar solubility of the PbBr2 in water or in pure water is 0.0131 molar. So do keep in mind that when water is added into the PbBr2 solution, there is no common ion, so the solubility will be remain the same. So in B2, now you are going to dissolve the PbBr2 in the KBr solution at where the concentration of KBr is 0.2 molar. So as usual, we are going to write the equation for the KBr. KBr is the salt, so they will dissociate completely. Concentration KBr will equal to the concentration of K+. Then next, we write the equation. And then we can focus on the ice table. Okay, for common ion effect question, you need to have the complete ice table because you obtain the Br negative from KBr, which is the 0.2. So at the row of the equilibrium, Pb2 plus only have X, while the Br negative will have 0.2 plus 2X. Then you write in the, substitute in the value into the KSP and also KSP expression. But do keep in mind that because the KSP value is very small, which is smaller or equal to exponent negative 5, then we are able to do assumption. So when we assume, means that we are going to assume X is very small, which is almost equal to 0. When this happens, 0.2 plus 2x will equal to 0.2. So, and then press the calculator, you will notice that the concentration of the PBBR, molar solubility of PBBR2 in KBR is 2.23 exponent negative 4. Similar method will be done for the question part 3, at where this time also lead to nitrate going to dissociate completely. So concentration Pb2 plus is equal to 0.2 molar. And then we also write the equation for the PBBR2, and then we have the ice table. So substitute in again, because the KSP value still exponent negative 6. So it is very small. So we make it 0.2 plus x approximately equal to 0.2. And then the molar solubility of the lead 2 bromide in lead 2 nitrate is 3.34 exponent negative 3 molar. So then for the question of part B, we're going to do the explanation based on the data or based on the molar solubility that we obtain. When we're comparing it, we will notice that Br negative is the common ion when the KBr solution is added. So then the concentration Br negative increase. According to the Le Chatelier principle, system will oppose to reduce the concentration of Br negative by shift to the left, so that more PBBr2 precipitate is formed. So as the result, the solubility for the lead 2 bromide is decreasing. Let's continue with objective question number 1. Consider the equilibrium of calcium hydroxide in water. What is the effect of raising the pH of the solution? So as we know, once the pH value increase, means that the pOH value going to decrease due to the pH plus pOH equal to 14. Once the concentration of pOH decrease, the concentration OH negative is increased. Okay, if you can roughly calculate based on the formula, pOH equal to negative log OH negative. So the concentration of OH negative increase basically is the disturbance that made by you. So what the system going to do? System going to reduce the concentration of OH negative. So refer back to the equation here. If the system would like to reduce the concentration of OH negative, means that they need to consume OH negative. If the OH negative is consumed, means that OH negative need to act as reactant. So, and then the equilibrium position shift to the left. So when we choose the option A, B, C, D, you will notice that the option B states that calcium hydroxide precipitates until equilibrium is re-established. So means that calcium hydroxide precipitate, which refer to the solid, which is at the left side. So the answer for question 1 is option B. Question number 2, expression for the solubility product for silver phosphate. So before we can write the KSP expression, it will be better we write down the chemical equation. So silver phosphate when dissociate will produce Ag plus, which is 3, while the PO4 negative only 1 more, but with the charge 3 negative. So based on this equation, we know that concentration of Ag plus need to be power of 3, and then concentration for the PO4 3 negative only power of 1. So the correct option is B as well. Question number 3. What will occur if 250 ml of 0.12 molar lead 2 nitrate, maybe you have to do some changes about here. Lead 2 nitrate should be PbNO3 is mixed with 200 ml of 0.07 molar NaCl. And then KSP value is given. When we look at the option here, we can see the word precipitate basically. So means that we are going to calculate the Q for this question. So before we can calculate the Q, we need to find out the concentration of lead 2 nitrate and NaCl after mixing, because the concentration now given here is before mix. So after mixing, the number of mole is same, but the concentration different. After mix, number of mole remain, but concentration will be changed, okay, due to different volume. Okay, then now let's start with the lead 2 nitrate. So number of mole for lead 2 nitrate will equal to number of mole of Pb2 plus, because 1 mole of lead 2 nitrate going to produce 1 mole of Pb2 plus. So because we have the concentration and we also have the volume, so we can use mv over 1000 to get the number of mole, which is 0.03 mole. Then at the same time, we also need to find the number of mole for the NaCl, and number of mole of NaCl this time will equal to number of mole of Cl negative. Again, which also mv over 1000, m is 0.07, v 250 over 1000, which will equal to 0.0175 mole. Okay, then now we need to calculate the value of Q. QSP will equal to concentration Pb2 plus, and then concentration Cl negative to the power of 2. Okay, how we know this? Maybe you need to write down. If you can't see it, then you need to write down the chemical equation. Pb2 plus equals plus 2 Cl negative equals. Okay, so concentration Pb2 plus that we calculate over here is 0.03, but don't forget we need to convert them to concentration. So the volume after both these lead 2 nitrate and sodium chloride mix is 250 ml plus 250 ml, which is 500. So I can divide by the 0.5 mole. 0.5 liter. Then the concentration of the Cl negative will be 0.0175, also divide by 0.5, but don't forget, you have to rise to the power of 2. And then multiply the answer, you will get the answer for the QSP is 7.35 exponent negative 5. Okay, then now we need to compare the Q value and also the K value as we do normally. 7.35 exponent negative 5, and then given 1.7 exponent negative 5. So means that Q value is larger. If Q value is larger, we know that the system will shift to the left, which will produce PbCl2. So the answer will be precipitate is formed. So option B and C will be out because Q is larger than K. So the option is A. Okay, normally we write down in form of Q compared with K, but this time the answer given us in different way of writing. Okay, thank you for staying with me up to here. So this is the final answer for question 2, 3, 4, and 5. And these are the answer for the objective questions. So we already complete the tutorial question for semester 1. So all the best in your PSPM, and we'll see you again in next semester.